Hello, everyone. We will start the session soon. Hello and warm greetings to all the participants, educators, and mentors worldwide. It is so lovely to have you here with 2 Bits Learning. I'm Abhiraman Vishwambaran and I'm excited to be your host today. I welcome all of you to the Masterclass series conducted on the background of the International Computing Olympiad ICO, proudly presented by Qubits Learning in association with Athena Education, Copperstone Education, and Be Curious STEM Learning. Our Masterclass series delivers expert-led session aligned with each competition track, providing participants with critical skills, actionable insights, and strategic guidance to succeed in the International Computing Olympiad 2025. Today's masterclass topic is data analysis for climate action. So if you have any questions regarding the ICO of this session, please write them in the chat box. We will address the questions during the question and answer session. So today's session expert is Mr. Shajas Ashraf. Mr. Shajas Ashraf is the head of implementation at Qubits Learning. He's an electronics and communication engineer and a passionate educator with over 12 years of experience. Mr. Shajas holds international certifications in data science and AI, making him a sought-after expert in the field. As a curriculum developer and author in computer science, Mr. Shajas has collaborated with 100 schools to implement CS and STEM curricula and has trained over 5,000 teachers. With his deep understanding of the challenges and opportunities in education, Shajas is driven by a passion to empower both students and teachers. We welcome you, Mr. Shajas Ashraf.
Thank you. Thank you, Brahman, for a warm welcome. I'm excited to be a part of this masterclass session.
Wonderful, wonderful. So before we begin the masterclass, I will give you a quick overview of the International Computing Olympiad 2025 and explain how students and mentors can use the Qubits learning management system. So you can write in www.computingolympiad.org to visit the International Computing Olympiad official website. This website is your resource for all things related to the ICO 2025. You can go about the website and find out what is the international computing is all about, how you can be a climate action hero and code for change. You can also find the different 4 tracks that we have for the ICO 2025 and also find the prices, certificates, and free access associated along with it. Participants also note that you have the important dates here mentioned in the website and make sure of May 15, 2025, it is the national submissions deadline. So please stay tuned of the important dates. And also along the top of the website itself, you can find the guidelines, which will take you through the general rules and regulations, the judging criteria, and the very specific guidelines for the participants. Also, we have an events page, which will let you know about the upcoming events happening parallelly with the International Computing Olympiad. So as I often say, most of you would have already joined, but for the International Computing Olympiad 2025, but let me just quickly take you through how you can join. You can come in the home page, you can find the Register Now button. You can click on the Register Now button, which will take you to the team registration. So you can start up by filling the team details by entering the team name, followed by the team size. The maximum number of people in a team is 3. An individual can also participate, following which you can enter the mentor details and the student details. And then comes the contest category selection, which will enable you to select a particular challenge for the particular track for the International Computing Olympiad. Then you have the declarations. You can tick the declarations by going through the guidelines. Once you have completely gone through the guidelines, you can tick the guidelines and then click a submit, which will take you to the payment gateway, where you will find the challenge that you have selected on the left and the corresponding entry fee associated with that particular challenge on the right. You also have a promotion code, so please stay tuned in our social handles so that you can find the promotion codes and avail a discount. So it is the mentor who will have to fill in all the details regarding the payment and do the submission formalities. So once that is done, the mentor will receive an email in his account, email account, which will have one, the Qubits LMS accessible link, two, the login credentials of the participants, three, the login credentials of the mentor himself. So the participants, the students can log in to the Qubits LMS link. They can log in with their credentials. So they can give their username and password and click a login, which will take them to the dashboard. So you will find different challenges. So I have all these challenges as it is a demo account. So since you have selected climate data analysis challenge, you will find that particular challenge here. You can find it along with the challenge details button. You can click on challenge details button, which will take you to the climate the climate data analysis challenge. So you can find the problem statement, you can go in depth about it, you can also find the guidelines and the judging criteria here. So since you have opted for climate data analysis, you get a preparatory course in data analysis. You can find it in courses, and you can find preparatory course at data science here. So you can click on that, and you can when you click on that, it will take you to the course overview, where you will understand what all you will be learning in data science. So you can go through the fundamentals of data science. You have the chapters here. If you click on the right, you have the breakdown of chapters. You can start off with the introduction to data science. So this particular chapter will have multiple video tutorials and checkpoints throughout. So you can see, you can find multiple video tutorials and checkpoints throughout the chapter. So students can prepare using these uh, resources, and they can get ready for the challenge. So once students are ready with these chapters, they can kick off their projects by clicking on My Projects. So this is how you do it. You click on My Projects, and then on the right, you will see Create New Project. You can select Python. And then you start writing your code here. So this is one important aspect of the Qubits LMS, where you can launch Python IDE or any other IDE from the platform itself. So students can run their code, write their code, run their code, save and collaborate with their peers and start off with their projects. So this is how students can use it. Now let's see how mentors can use it. Mentors can log in with their login credentials. So once they give their login credentials and login, this will take them to their dashboard. So since it is climate data analysis challenge that the participants have selected, so the mentor will have in his dashboard listed the data analysis challenge along with the start submission button. So you can click on that. So once you do that, the dashboard will show you the view contest details. So mentor can go about and find about the contest details, the submission protocols, the judging criteria, etc. Also, you have the rubric grading criteria. So which is nothing but the judging criteria. So you will have the different criterias on the left. Here you can see communication, statistical and computational methods, etc. So mentor can find out about the rubric grading with the levels and the associated points associated along with it. And after you do that, mentor can start off with the submission protocols. So firstly, they can upload a code file which is less than 4 MB directly here. And those files, code files which are more than 4 MB, they can paste the code file URL here. And secondly, for the video link file, they can upload the presentation video. They can paste the video link here. And thirdly, for all those PPT files which are less than 4 MB, they can directly upload it here. And for those presentation files which exceed the size limit of 4 MB, they can paste the presentation file URL here. So this is how mentors can do it, but please note that it is the mentor who will have to submit the project. So make sure everything is ready. Once you submit, it is considered final. So this is how students and mentors can use the Qubits LMS. Now, I request Mr. Shajas Ashraf to start the masterclass, Data Analysis for Climate Action. Over to you, Mr. Shajas.
Yeah. Okay. Thank you, Abraham. Good evening, everyone, and welcome to the International Computing Olympiad 2025 Masterclass. So I'm excited to be here today to guide you through a crucial and impactful topic, data analysis for climate action. In this session, we'll explore how data can play a pivotal role in understanding climate change and helping us take effective actions to protect our environment. By the end of today's session, you will have a better understanding of how data science and analysis can be leveraged to address one of the biggest challenges facing our world today, that is climate change. I encourage you to engage actively, ask questions, and think critically about how the skills we learn today can be applied to the real world challenges. So in this challenge, you will take on the role of a climate data analyst and use data to understand how climate change impacts our natural resources and biodiversity. The goal is to explore reliable data sources and analyze trends that help inform others about the climate issues. This challenge is for students ages 14 to 19 and encourages you to share your insights to drive real-world action. It's a great opportunity to learn how data can spark change and make a positive environmental impact. Let's dive into how you can get involved and start analyzing climate data. To begin any project, we must first identify the problem. So through data analysis, we can then arrive at a conclusion and solution to address that problem. In this case, CO2 emissions are a major driver of climate change, and understanding why we should care about them is essential. Daily activities play a significant role in contributing to CO2 emissions. For example, when we drive cars, use electricity for cooking, shopping, flying, or even streaming videos, we are relying on fossil fuels, which releases CO2 into the atmosphere. Many of these everyday actions, though often overlooked, are key contributors to the growth levels of CO2 emissions. As CO2 accumulates in the atmosphere, it traps heat, causing the Earth's temperature to rise. This leads to more extreme weather events like floods, droughts, and heat waves, and it accelerates glacier melting, contributing to rising sea levels. Now that we have identified the problem, next, we are going to analyze the problem. We are going to look at how CO2 emissions have changed over time and see if we can find any correlation to the rise in global temperatures. We'll examine the data from the past to check if there is a pattern. As CO2 levels increase, do temperatures also increase? This is an important question because if we can find this link, it will help us understand how human activities are affecting the climate. Today, we'll dive into the data and to see what we can discover about the relationship between CO2 emissions and temperature changes. So let's see how what data shows. Now let's look at the steps involved in building the project. So in this section, we'll break down the entire process into manageable steps that will guide us as we work through the data analysis. This includes how to collect data, clean the data and process it, explore trends, and visualize the findings. Let's take a detailed look at the steps to build the project. We'll break it down into 5 key tasks. First, we need to gather the data from trusted sources like Our World in Data, Kaggle, NOAA, or NASA. These platforms provide accurate and credible data sets that are crucial for your analysis. Once we have the data, the next step is cleaning. This involves removing duplicates, handling empty cells, and correcting any errors or outliers in the data. Cleaning is essential to ensure that your analysis is accurate. After cleaning the data, we'll visualize how CO2 emissions have changed over year by year. This step will help you understand the trends in emissions over time. Next, we'll look at how global temperatures have changed over the same period. We'll plot temperature anomalies to see how much the temperatures have deviated from the average. Finally, we'll explore the relationship between CO2 emissions and global temperature changes to see if there is a correlation that might indicate how rising CO2 levels are influencing the global warming. So these steps will help guide your analysis and ensure that clearly present your findings. So as the first step, I searched for the data sets and I found a data set on CO2 emissions from Our World in Data, which is sourced from the Met Office Hartley Center HAT 5 2025. This data set contains data on CO2 emissions from 1950 onwards, and it's a valuable resource for our analysis. This data sets includes multiple columns such as year, population, GDP, cement CO2, CO2 per capita, CO2 growth. This data will allow us to track how global CO2 emissions have evolved over the years. As we analyze the data, we will be able to look for trends and relationships between CO2 emissions and other variables such as population and economic growth. Then I searched for the temperature data and I found the temperature anomaly data set from NASA provided by National Aeronautics and Space Administration and the Goddard Institute for Space Studies. This data set tracks temperature anomalies from 1880 onwards. So what is temperature anomaly? In simple terms, temperature anomaly shows how much warmer or cooler a year or month was compared to the typical temperature over a much longer time frame. This dataset includes year, month, and temperature anomaly. We'll use this data to visualize global temperature trends and anomalies, which will help us understand how temperatures have shifted over time and correlate with the CO2 emissions. So next up, let's talk about the data cleaning, which is an essential step in any data analysis process. So before we can start drawing conclusions from our data, we need to ensure it's clean and ready for analysis. This involves checking for any duplicate values, empty cells, and outliers that could skew our results. We can perform data cleaning using different tools such as Microsoft Excel, Google Sheets, Python, and there are different other tools as well. So by cleaning our data, we ensure that the insights we gain are based on accurate and reliable information. So let's move forward and see how we can clean and process our data for the next steps. For this project, I have selected Python as the tool to analyze the data due to its powerful capabilities for handling and processing large data sets. We'll open the Python IDE in the Qubits platform and walk through each steps of the analysis process together. So first, I'll be loading the data into the Python platform. Then I'll use Python functions to clean the data, such as removing the duplicates, handling missing values, and correcting outliers. Then I'll write a program to visualize the CO2 emissions, and I'll write another program to visualize temperature anomalies. Finally, we'll correlate the two data sets, and I'll do a prediction of for the next 50 years as well. So by using this Python project, we'll be able to effectively analyze and visualize the data to uncover meaningful insights. Okay, so let's go to the Qubits Python IDE. So I have logged into my Qubits account now. And let's go to the My Project section. So as Mr. Abhiraman mentioned, you can create new projects from here. So we have different IDs available like Python Web Editor, Scratch, JavaScript, Scratch Junior, and Java. So I have mentioned before, I have selected Python for my data science project. So as a first step, based on my step, what I'm going to do is visualizing the CO2 emission. Okay, so I have prepared my program here. So before moving to the program, the first step what we have to do is we have to import the data set to the Python IDE. So you can directly do that from here. There is an option, import file or folder. You can click on that one, and you can click this plus icon. So if you click on this plus icon, it will open a dialog box, and you can select your data set from your computer. So I'm selecting my data set, then click import. So you can see here, the data set is visible over here, and we can use the same data set in our program now. Okay, so let's go through the program. So you can see here, first I have imported the necessary libraries, which are pandas and matplotlib. Then I have given the instruction for loading the data set, which is the CSV file, and then comes the data cleaning part. So here I'm just filtering the CO2 data because I checked manually my data for any empty values and everything. So I'm not adding any code here to remove the empty cells or anything. I just want to filter the data to world, because in this data set, it has the data of all the countries and also different continents and then the world. So I'm selecting only world from the data set. So I'm filtering the data set here, and then I'm plotting the graph. So you can see here I'm using the plot function, and then comes the plotting and labeling of everything. So you can see I'm giving a red line for the graph line, then I'm labeling the x-axis, y-axis, giving a color for the y-axis label, setting a title for the entire plot, then adding grid for better readability. Then I'm also enabling the legends, and then finally plotting on the screen. So now let's run the program and see how the graph is. So this is how the graph is. So I'll just zoom in. So you can see here, as I mentioned, there is a x-axis label, which is year, and y-axis label in red color. That's why I mentioned it here. We are changing the color to red, and the color of the line is also red, and there is a legend and then title for the graph. So that's how I have created my plot. Now coming to the insights from this graph. So we can clearly see that there is a high rise in the CO2 emission after 1950, and it's going again higher and higher. So that's how the CO2 emission graph is. So my first part of the project is done. So moving to the second part, which is I'm going to visualize the temperature anomaly for the last over years. Okay, so I have my program ready here. I have also uploaded the CSV file. You can see I have imported the libraries, loaded the data, then the data cleaning. So here you can see I'm cleaning the data and I'm making sure there are no errors, because when I check the data set manually, I found some errors there. And I also want to make sure that all the values in the temperature anomaly column should be numeric. So I'm using this function, and also I'm removing the missing values from that column, and then the plot functions. So we are using this plot function, and we are labeling the x-axis, y-axis, adding a title for the graph, then adding a grid, and also enabling the legend, finally displaying the graph. So let's run the program. And this is how the graph is generated. So as I said, you can see here, the color of the graph is blue, because that's what we have mentioned here in the code, in the plot function. And we have the legend, we have the x-axis label, then y-axis label, title for the graph. Now, coming to the insights of this graph, you can see from 1960 onwards, there is a like high rise in the temperature anomaly, and it's going higher and higher till 2025. So that's how the global temperature anomaly is currently. So now we have two separate graphs. Okay, so if I overlook my steps of the project, now I have visualized the CO2 emission, I have visualized the global temperature anomaly. Third one, I want to get a correlation between these two graphs. Okay, so let's combine these two data sets and create a program to visualize both the values in one graph. Okay, so I have prepared that same program here. Okay, so first I imported the necessary libraries, then loaded both the data sets together here, and filtering the world, only the world column for CO2 emission. Then I'm merging the data sets. Okay, so while merging, there should be one common parameter. Here we are considering year as one common parameter, and we'll be plotting the values in each year. Like for example, we'll plot the value of 1960 of CO2 emission and temperature together, so that it will be on the x-axis and the other values will be on the y-axis. So you'll be able to see both graphs together in one plot. Then we are plotting that. So you can see first we plot the CO2 emissions, then we plot the temperature anomaly in the second y-axis, then we are adding the title, then grid, and displaying the plot. So let's run the program and see how it works. So this is how the correlation graph is. Now you can see the y-axis it's marked on both the sides. So this side you can see the CO2 emission, which is red in color, because the red line represents the CO2 emission, and the blue line represents the temperature anomaly. That's why this is marked in blue color, and here is marked on the x-axis, and then there is a title for the graph, and the grid lines are also enabled. So when you come to the insights from this graph, it's very clear that there is a correlation between temperature anomalies and the CO2 emission. You can see from 1960 onwards, both the CO2 emission and temperature anomaly is increasing, and it's so that means there is a correlation between CO2 emission and the global temperature anomaly. All right. Now, the next step. So we have come to the conclusion that there is a correlation between the global temperature anomaly, and the CO2 emission. So next step, what I'm going to do is, if we are going in this scenario, what will happen in the next 50 years? So we can, based on this data analysis, using some other prediction methods, we are going to predict what will happen to the CO2 emission and global temperature anomaly in the next 50 years. So I have prepared another program for that. So here we are using another model called Serimax, and this is an extension from ARIMA model. This model is used for time series forecasting, and it's called auto-regressive integrated moving average. So we can predict the data based on the previous data. We can predict the data for the next like 50 or 100 years, whatever you want to give, you can give. And why we are using Cyrimax here? As I said, this is an extension to the ARIMA model, because Cyrimax is seasonal ARIMA. Because here we are considering one season as 1 year, and we are giving the Cyrimax parameter as 12 here, so that each year will be considered as one season, and then it will predict the data for the next 50 years. So in the beginning, coming back to the beginning part, so first we'll import all the necessary libraries, then load the data set, filter, that means the data cleaning part, and also merging the data. Then we import, or we like fit the Sedima model to the CO2 emission and the temperature anomaly. You can see this is how we are fitting that. And then we predict the data for next 50 years. You can see here we are giving steps equal 50 in this function. So if you change it to 100, you will be able to like predict for next 100 years. And then we plot it using the plot functions. Okay, so let's run the program. So you can see here the two graphs uploaded together. You can see the blue line represents the temperature anomaly, and the green line represents the CO2 emission, and the prediction is represented by the dotted lines or dashed lines you can see here. So this is the prediction for CO2 emission for the next 50 years, and this is the prediction for temperature anomaly for the next 50 years. So let's get into the insights of this graph in detail. Okay, so I'm coming back to my presentation. Okay, so from this graph, we can looking at the graph, we can see a significant rise in CO2 emissions starting around 1950, coinciding with the increase in industrial activity. So this rapid increase in emissions is a major driver of climate change. And also there is a strong correlation between the increase in CO2 emission, that is represented in the red line, and the rise in temperature anomalies, which is represented in the blue line. As CO2 levels rise, you can see the global temperatures are also increasing, which points to the direct impact of greenhouse gases on global warming. So as I mentioned before, the red dash line indicates predicted CO2 emissions. The projection shows that the emissions will continue to increase for the next 50 years, suggesting that the current trend will persist unless significant actions are taken to reduce emissions. Similarly, the dashed blue lines shows the predicted temperature anomaly. As the CO2 emissions continue to rise, the temperature anomaly is also expected to increase, reinforcing the need for urgent action to mitigate the climate change. Now, in this project, so let's summarize everything. So we started by identifying a problem statement, the impact of rising CO2 emissions on global temperatures. We then proceeded to collect data on both CO2 emissions and temperature anomalies. After gathering the data, we cleaned it to ensure its accuracy and relevance for analysis. We then performed the data analysis to understand the relationship between CO2 emissions and temperature anomalies. And we also created predictions for both CO2 emissions and temperature anomalies for the next 50 years. Our findings revealed a strong correlation between rising CO2 emission and increasing global temperatures, which is consistent with the known effects of climate change. From the analysis, we concluded that human activities, particularly the burning of fossil fuels, are significantly contributing to the rise of global temperatures. Now let's discuss the necessary steps we can take to reduce CO2 emission and help stopping or mitigating the climate change. How can we reduce CO2 in daily life? So instead of driving cars, walking, biking, or using public transport helps reduce the amount of fuel burned, leading to cleaner air and fewer emissions. Simple actions like turning off lights, using energy efficient appliances, and switching to renewable sources when possible can significantly reduce your carbon footprint. Transporting food and wasting it contributes to the CO2 emissions. So, by eating locally grown food and reducing food waste, we can help lower these emissions. Be mindful of your purchases. Supporting eco-friendly products and recycling or reusing items instead of buying new ones helps reduce the demand of products that cause CO2 emissions during your production. Trees absorb CO2 from the atmosphere and help cool the planet. Supporting green spaces in your community and planting more trees can make a positive impact. So by making all these changes in our daily habits, we can all contribute to reduce CO2 emissions and fighting climate change. The data analysis today clearly shows the impact of CO2 emissions on global temperatures, and it's clear that immediate action is needed to reverse the current trends. Through collective efforts such as those listed above, we can reduce emissions and mitigate the long-term effects of climate change. As we wrap up today's session, I would like to share some sample project ideas that you can explore further in your own research or future projects. These ideas will allow you to apply data analysis to various aspects of climate change. So the first one, climate impact on agriculture. So in this project, you can analyze how temperature and rainfall changes affect crop yields like wheat, rice, or maize. Second one, the climate change and natural disasters. Explore the link between rising temperatures and the frequency or severity of natural disasters. The third one, impact of deforestation on local climate. Study how deforestation impacts local climate patterns like temperature and rainfall. Then fourth one, endangered species and climate change. So in this project, you can investigate how climate change affects biodiversity and animal migration patterns. So these are just ideas at the beginning. These are countless ways you can use data to investigate the ongoing effects of climate change. I encourage you to think critically about how climate data can be used to create positive change. Here, I'm showing some of the most reliable and reputable data sources that are commonly used for for climate data analysis. These sources provide accurate and comprehensive data sets that are essential for understanding trends in climate change, CO2 emissions, and their impact on global temperatures. So let's go through each one. Our World in Data, this source provides comprehensive data sets and visualizations on global issues, including climate change. Kaggle, a platform offering variety of data sets for data analysis, including climate-related data. Then NASA offers satellite data and climate research focusing on atmospheric conditions and global temperature changes. Then National Oceanic and Atmospheric Administration provides extensive climate and weather data, including temperature, precipitation, and sea level changes. World Bank supplies data on global development, including environmental factors and CO2 emissions by country. Intergovernmental Panel on Climate Change publishes authoritative reports on climate science impacts and projections for global temperature changes. United Nations Framework Convention on Climate Change. This source tracks global climate agreements and emissions data from countries aiding climate policy development. Environmental Protection Agency provides data on environmental health, CO2 emissions, and air quality, focusing on the US but with global implications. Some of the most popular data analysis tools that are widely used for data analysis are given here. So you can use these for creating your projects. So the first one is Python. As you know, it's a versatile programming language. So this can also be used for data analysis, visualization, and machine learning with libraries like Pandas and Matplotlib. Then R is a statistical programming language known for its power in statistical analysis and data visualization. Excel can be widely used as a spreadsheet tool, but it can be used as a basic data analysis tool also. It can be used for manipulation and charting as well. And Google Colab is a cloud-based platform for running Python code. It's very ideal for collaborative data analysis and machine learning. And then Power BI, it's a business analytic tool that helps create interactive visualizations and reports from raw data. Then Codap, a free user-friendly tool for data analysis, commonly used in educational settings to explore and analyze data sets. So these tools are some of the most common choices for data analysis, but there are many more available depending on the complexity of the task and the type of analysis needed. Each tool has its own strength depending on the needs of project. So you are free to explore the different tools and you can select any one based on your project. So I hope this session was informative and helpful. Now I would be happy to take any questions you may have.
Thank you for delivering such an outstanding session, Mr. Shajas Ashraf. I'm confident the participants found your masterclass on data analysis incredibly insightful, and they will walk away with valuable knowledge and skills today. So now we have some questions. The first question is, do we need to perform predictive modeling, or is analysis and presentation sufficient?
It is recommended to include predictive modeling, but however, it depends on the end goal of your project.
Okay. Then we have another question. Is programming necessary for data analysis?
No, while programming, you can help with large data. The programming can help with large data sets and more complex analysis. You can also use the tools like Excel and Google Sheets for the data cleaning and visualization also.
Okay. Now we have another question. How important is data cleaning before starting an analysis?
Data cleaning is extremely important. As I have mentioned in my presentation, it ensures that your data is accurate and reliable by eliminating the duplicates, correcting errors, and dealing with the missing values or outliers, so which could distort your analysis.
Okay. Now there's one question. Can data analysis help in combating climate change?
Yes, we have mentioned different project examples for that. So data analysis allows us to identify patterns, track emission trends, and assess the impact of climate change on different sectors.
Okay. Now we have one question. How do you make a CVS file using Excel and then using the project editor on the website?
Um, you mean, yeah, how do we make CSV files, right?
CSV, yeah.
Yeah, so you can use Excel and you can copy paste the data there. And then if you click on file, you have an option to save it as or export as a CSV file. You can use that option. You can either use Microsoft Excel or you can use Google Sheets for this purpose.
Okay, there's one more question. Do we submit a directory or a project file?
Project file, you will have to submit the project file as the if you're using Python, it should be .py file.
Mm, let's go. How to upload a CSV file?
Yeah, I'll just share my screen and quickly show that.
Okay.
So here you can see in the Qubits Python IDE on the left side, you can see there is a file menu and there is an icon here, import file or folder. So if you click on that, you will get an option like this, and you can click on this plus icon. Then it will open the dialog box which shows your computer files. So you can go to the folder where you have saved your data set in the CSV file format, and then you can select that and you can open it. After that, you can click on this import, then it will be added to the Qubits Python ID.
All right. So we have more questions. What kind of data sources are allowed or recommended for the challenge?
Yeah, only thing is that you should use a reliable data source. I just mentioned some of the data sources that we can use. So it should be a reliable data source. That's the only thing that we recommend.
Okay, moving to the next question. Can we use pre-cleaned data sets, or do we have to perform the cleaning ourselves?
Actually, if you check out the judging criteria, you can see there is specific marks for data cleaning. So it's better if you show data cleaning by yourself. So you will get more marks in that.
Okay, now we have another one. Are there specific climate indicators we need to focus on? Example, carbon dioxide levels, temperature anomalies, sea level rise, etc.
Okay, no, nothing like that. It should be related. The only, the theme of the competition is climate awareness. So you should focus on the climate. So it can be anything, but it should be related to the climate awareness.
Okay. Another question, can we use APIs like NOAA, NASA, or Open Weather Map?
You can use APIs and you can use the necessary libraries and use it in the Python program. You can use APIs. That's fine.
Okay. What kind of data sources are allowed or recommended for the challenge?
Yeah, I already answered that question. That is, it should be a reliable data source. So I mentioned some of the data sources which are popular and we can rely. So you can use any of those data sources.
How much historical data should we include in our analysis?
That depends on your project. Based on your project, you can mention that. So it depends on the data set, or it depends on the data that you're selecting. So it depends on the project that you're working on.
Now, the one, what format should be the final data set or report to be submitted in?
While when you're submitting the entire project, if you are using, let's say, if you're using Python IDE, it should be in the .py format. Or if you are using Google Colab, that also you can download as Python programs and upload it. So based on the tool that you are selecting, you have to download in that specific format and upload it to our platform.
Okay. Are we expected to compare data sets across regions or time periods?
No, it's not mandatory to find a correlation. It's based on your project, as I said in the beginning. Because, for example, if I take the case of CO2 emission and global temperature, there I have to show that, or I have to show an evidence that there is, because of the CO2 emission, this is happening. Global temperature is rising. That's how it is getting connected to the climate change. So I just showed some data evidence to make it clear that this is happening. So if that is the case, if you are also doing something like that, then you can show the correlation. Otherwise, it's okay. You can show with one data itself. That's fine.
Okay. We have a few more. Can we analyze data at a local or city level, or should it be global?
No, it's not necessary to be a global data. It can be even one country or one city. It's up to you. So the you as a project, it's you have full freedom to use any kind of data. So as I said earlier, it should be reliable and it should be an accurate data. That's what we are expecting.
Okay. How do we handle missing or incomplete data entries?
Yeah. So as I said, this data cleaning is a big process. So if you check the preparatory courses in our platform, you will get an idea how to do this data cleaning process. And as I mentioned, one thing you can do is you can do it manually. You can open the CSV file in Excel, and then you can search for missing values or duplicate values, and you can remove them. That is one option. Other option is that you can use Python for automated data cleaning process. There are different functions to remove the empty values, and there are different functions to find out the outliers. There are different functions to remove the errors and everything. So you can use those functions and clean the data and make sure your data is cleaned.
Okay. What tools are allowed in bracket Python, R, Excel, Tableau, etc.?
Yeah, I showed some samples already. That is Python, R, Excel, then Google Colab. Then you can use Power BI, Codab. There are different tools available. You can use any of them.
Can we use machine learning models or just statistical analysis?
You don't have to use machine learning models. You can also use a statistic analysis. It's fine.
Okay, we have two more questions. Should we include correlation and regression models in our analysis?
Yeah, this is also like it's not mandatory to include everything in your project. So based on your project and based on your analysis, you can decide whether you have to show the correlation and whether you want to do the prediction. So as I said before, based on your project and your way of explanation or what you want to prove, that's the major thing depends here.
Visualizations bracket graphs dashboards mandatory or optional?
Visualizations are mandatory, but you can show with the data also. But what when it comes to data analysis, it's better to show with the graphs.
Can we include projections or forecasts in our project?
Yes, yes, that's what I just showed in my example. So you can use the forecast option. That's the prediction is actually forecasting. We are using time series forecasting in our program to forecast the values for the next 50 years or 100 years.
Okay, that's all we have. Thank you, Mr. Shajaz Ashraf, for patiently answering all the questions and enriching our masterclass series today. It is much appreciated.
Yeah, thank you. Thank you for having me. And it was a pleasure to be a part of this session. And I hope the insights shared today were helpful. And I also would like to wish all the best for all the ICO participants.
Thank you. Thank you. Thank you, Mr. Shajaz Ashraf. Much appreciated. Participants, please note that we have a Google form for feedback shared in the chat pod. Kindly fill it out. We would really appreciate it. Now, moving on to the thanks part, we at Qubits Learning hope that today's masterclass series, Data Analysis for Climate Action, has enriched you with a deeper understanding of the competition track. Qubits Learning would like to thank our partners, Athena Education, Copperstone Education, and Be Curious STEM Learning for being with us in this incredible knowledge oriented competition. I sincerely thank Mr. Shajaz Ashraf for his clear-cut explanations during the masterclass, which significantly, I'm sure, has enhanced the students' understanding of the subject. His engaging delivery and carefully selected examples made the session both memorable and very impactful. We hope you found our masterclass series very fun, insightful, and inspiring. Thank you for your enthusiasm and engagement throughout the sessions. We are excited to see your projects come to life and make a real impact. Your creativity and hard work have the potential to drive meaningful change, and we can't wait to witness it in action. To further support your preparation for the upcoming competition, we invite you to visit our YouTube channel where you can access all the masterclass videos. These recordings are packed with valuable tips, strategies, and insights to help you excel. Uh, you can find the link for the YouTube channel in the chat box. So I kindly remind you once again to take note of the national submission deadline, which is May 15th, 2025. Please ensure that requirements are completed and submitted well before the due date. So I see there are some more questions here, Shajaz.
Yes, yes.
Yeah. How can I send our HTML, CSS, JSS file?
They can directly submit to our platform. There is an option for submitting it. So they can you can directly submit to the platform.
Okay. Okay. Is HTML allowed?
HTML for data analysis, it's allowed in the sense, yeah, you can use it, but it's not recommended to use HTML because it's very difficult. Uh, it will be difficult for you, or it might be difficult for you. So better if you use Python or any other tools, which is like majorly used for data analysis, that will be easier for you instead of HTML.
So there's one more question. Can we use AI or make an AI model?
Yes, actually, the prediction, the time series forecasting, it's a part of AI. So if you're doing a prediction or if you're forecasting something, that comes under the artificial intelligence. So it's a part of AI.
Okay. Okay. Once again, I remind all of you to take a note of the national submission deadline, which is May 15th, 2025. So please ensure that all the requirements are perfectly completed and you submit everything well before time. So to get all notifications, please follow us on LinkedIn and Facebook we will have all the updates there. You can also write to us for any ICO related information to connect@computingolympiad.org. So we would like to wish all the participants now from Qubits Learning the very best of luck in their respective challenges. This is your host, Abhiraman Vishwambaran signing off. Thank you all and have a great day.